All right, for this set of notes, we're going to be looking at domain and range again, but we're going to be looking at domain and range where not all of the x values are included, and there's going to be some discontinuity, whether it be removable discontinuity, there's a point missing, whether it's going to be gap discontinuity or jump, or it's going to be infinite discontinuity. So just like before, we're going to look at where does my graph start, and we're going to go left to right for the domain. So when I look at the domain, I have an arrow. So I automatically know that I'm coming from negative infinity on this side. And I continue, but I can't go any further. There's a section here missing. And this point right here is not included. So when I look at that value, I know that I'm stopping at the x value of -1. Now, I'm not going to include the numbers in between here because there is no graph values or x values in between there. So we're going to start back up on the other side at +1, and then we're going to keep going to the right, and we come to another arrow. So because we come to that other arrow, we're going to continue to go to positive infinity. So essentially, we're going to the left, and we're going to keep going to the left. We're skipping all the x values from -1 to 1, and then we're going to continue to go greater than 1 to infinity. So the way that we write that is we're going to stay from the left, we're coming from negative infinity. We're going to stop at 1, and it's going to be a parentheses because it's the open circle. Now, because there's a section, this is an or statement. Okay, so or, which in notation is a union, and because we're going to do a union, there are two separate sections. We're going to say union, and then we're going to start on the other side, and we're going to go from 1 to infinity, and making sure that the 1 is also in a parentheses and not included. Now for the range. Now the range is bottom to top, so we start at the y value of 0, but the y value of 0 is not included. And we're going to keep going up, and we're going to keep going up on both sides. There are all those y values in between that are included, and we're going to keep going up on both sides. So as the range is going up, it's going to go to positive infinity. So the range does not include 0, but it starts there, and it goes up to infinity. So you're always looking for where are there pieces that are disconnected. Now, for the domain here, starting from the left side, we're coming from negative infinity because there's an arrow. So negative infinity, we're going to keep going to the right. As we go to the right, we come to this section that is not part of the graph. That is at +1. Now, when I go to the other part, because technically there's a jump there, that jump shows me that that is also not included. So even though there are 2 points that are lined up, neither one of those are included, which means that the 1 is not included on either one of those graphs. So we have to indicate that. And then we're going to keep going to the right, and as we keep going to the right, we're going to be going to positive infinity for my x's. So the way that we're going to notate this, we're going to say we're coming from negative infinity. We're going to stop at the x value of 1 with a parentheses. And then we're going to union, because we're going to a different section. We're going to also say that we're starting at 1, but that one is also going to have a parentheses. So because there's parentheses here and here, that 1 is never included, which is exactly what should happen because they're both open circles. And we're going to say that we're going to infinity. So again, if we're on the number line, okay, we're saying that we're coming from positive infinity. And then right here we have an open circle because there's no values included. And then we're going to be going to positive infinity. So essentially it includes all the x values except for the +1. Now the range is a little bit different here because the lines are vertical. There's no numbers going up and there's no numbers going down. So we got to notate this a little bit different. So right here, we have a part of the graph. Yes, I know there's an open circle, but there's a bunch of other points on the line that are y values. So that y value is at -1. There's nothing in between. So between here, there's no other y values. There's no other y values above this or below this. So this other y value, and the only other y value that's included is that positive 1. So again, we only have 2 y values that are included in this whole graph, and those y values are -1 and +1. We are not going to use the parentheses or the brackets because we only need to state 2 numbers. We're going to use the set notation. Because my graph is not going up or down, we're not including all of the numbers in between. We're only including 2 numbers, and the 2 numbers that we're including are 1 and -1. So we use the set brackets to show that we are only including those numbers and not everything in between the interval. All right. So let's go to our next graph. So there's a lot more pieces here, so we got to make sure we analyze this. All right, so starting on the left side for the range, we have a value that starts at -4, but -4 is not included. So we're going to start with a parentheses, and then we're going to keep going to the right, and as we go to the right, we can see that we stop at a x value of -2. Now that -2 is included, so we're going to put a bracket there. Now, there is a section of the x's that are missing. So between here, between -2 and -1, we don't include those x's because there's no graphs in between there. So we're going to pick back up at -1. -1 is included. And we come here to the next part, and right here we have a jump. Now here's where you got to think for a second. Okay, I 100% understand that this is an open circle here where this x is not included. But it is defined by here. Now it is discontinuous at this point because it's disconnected, but that x value of the domain is included. So I don't have to stop, I guess I don't have to chunk up and make this 2. I don't need a union here because I don't have to stop at -2 because, or at +2, because this 2 is going to fill in the 2 that's missing there. So I'm going to keep going. Oh. Let me get, so I'm a union here. We started back at bracket at -1. So I'm not going to say that it goes to -2 because I know there's a jump there, but the 2 is still included. I don't need to state the domain of 2 because 2 is still included in the domain. What I do need to do is say that the x's are going to continue to go to the left, to the right, and they're going to continue to go to the right to positive infinity. So think about a number line. So essentially we're saying from -4 to -2, we're going to say that -2, and it's going to keep going to infinity because that +2 is going to get filled in, which means there is a x value that's included in the domain there. So I'm going to kind of put an arrow here, and I'm going to put x equals 2 is included. Okay. Now, the range. So from the range, we're going from the bottom. So most students will look at this and they'll say, okay, we're starting right here. However, there's an arrow here. That arrow is going to keep going down. So that arrow is going to take over the fact that there is nothing included here. So we're actually coming from -infinity at the bottom. Okay, so we're going to come from -infinity. And we're going to go up, and these numbers, so I know that there's a disconnect here, but there's also values over here that are included. The only part of the range that's not included, that's disconnected, if I think about the ranges, this section right here. There are no graphing pieces in this section right here for the y. So that means that we are going to stop the y values at -1. And then we're going to pick the y values back up at +1. So here, it's going down to -infinity, and it's going to stop at +1, or excuse me, -1. Now, that -1 is included, so we need a bracket, union, and then we're going to pick back up on the other side at 1. Now, remember, there's no open circle, so that is still included, which needs a bracket. So the question is do we keep going up or do we stop? Well, if I look at it, I have parts here, but my y values are going to stop and go no higher than positive 5. So my range is going to stop at positive 5, but positive 5 itself is not included. So we're going to say that from 1 to 5 is the last part of my range, but I need to make sure 5 has a parentheses because there is an open circle here. So just to be clear, there's an open circle right there, which means it's not included. All right, I'm going to skip the 2 equations right quick and come to this one. If you notice that there is some infinite discontinuity here, there is also a vertical asymptote that's shown. You don't normally see the vertical asymptote, but I also should be able to see that this is leveling out to look like a vertical line. So I know this is an asymptote because that invisible wall is keeping it from crossing any further. So if I read the domain, my domain is going to be my x values, and technically my x values are going to start where that vertical asymptote is. However, the vertical asymptote is not included, okay? So we're going to start at -3 with a parentheses. That is going to level out at -3, but it doesn't include -3. And then we're going to keep going to the right until we get to positive infinity. So that means that we're including all the x values from greater than -3. So we're going to say -3 to infinity. Now, my range, we're coming from the bottom, even though the... All right, so we know we're coming from negative infinity. Even though the x values stop, the y values are going to keep going down. So if my y values keep going down, we know that negative infinity is the first part of our range. And then, of course, we're going to keep going up. Now, I know that this is going to the right, but even though it's going to the right, it's still going to keep increasing. It's not going to be a fast increase, but it is going to continue to increase to the right. So that means that as it goes to the right, it's going to keep going up to positive infinity as well. So my range here is from negative infinity to positive infinity. All right, so let's kind of go back to our domain and discontinuity. So the domain, one of the things that you're going to look at when you do domain, there are actually a couple of rules. And the rules that you can look at in an equation, one, in the denominator. So if I have a fraction and I have a denominator, you can never have a fraction that has a denominator equal to 0. So you would have to figure out, is there any value that would cause the denominator to equal 0? There's also another rule about even roots or square roots particularly. So if I ever have a square root, square roots can never have negative numbers inside. So the numbers inside of my square root, regardless of what they come to be, always have to be greater than or equal to 0. We can take the square to 0, but we can't have a negative number because technically the opposite of something squared is the square root. Well, if you think about it, let's say I have 2 squared. That means 2 times 2, that'll always come out to be positive 4. But what if I have negative 2 squared? Well, that's going to be negative 2 times negative 2, so that's still going to turn into positive 4. So no matter what the number is, when you square it, it always comes out to be positive. So because it always comes out to be positive, I can never have negative numbers inside of my square root. Now we're going to kind of look at this, and we're going to look at it, and then we're going to check it graphically. So for this one, I absolutely have a domain value that I need to analyze. So remember, the domain can never be equal to 0. Well, if I look down here, I have an x in my domain. So that means that my x value can never be equal to 0. Well, if I think about that on a number line, that means that 0 is right here. So my graph, or my x's, can include everything other than 0. So if I state that, I'm saying that it's going to come from negative infinity, go to 0, pick back up on the other side of 0, and go to infinity, because I'm having to skip over that one number, which is 0. So if I put this into Desmos, and I'll look at it. Well, oh, it was zoomed out, sorry. So I'm going to put my fraction in, and it was x squared minus 2x over x. I believe that's what it was. Yep. So right now when I look at it, it looks like it's just one continuous straight line. But we said, okay, we said that it couldn't include 0. So if I go to the x value of 0, so basically if I click and drag a dot and I go to 0, you can now see once I hold it there that at 0, I have an undefined open circle. So the thing about Desmos is Desmos will show you open circles after you find them. They're not going to show you anything that's undefined until you are able to identify that that's the x value that's not defined. So I am including everything before 0 on this side. So remember, we're coming from the right. So we're coming from negative infinity on the right, on the left. And then we're stopping at 0, and it's not including 0. It's undefined. There's an open circle there once I find it. Hold on. Okay. So once I find that open circle and I know it's undefined, I'm going to take that and say, okay, it's going from negative infinity to 0. And then 0 on the other side and go to positive infinity to the right. Also in Desmos, if you go to the little setting option, once you put the equation in, you can hit the table. Now, this table right here will show you any value you want to know. So you can see at 0, it's undefined. I could find the value of 20 on that graph, and it's going to tell me it's 18. So you can find any value. It's just a matter of, okay, can I verify that it's undefined and there's a value missing? So what is the point of discontinuity? Well, the point of discontinuity is a removable point. I hope we all saw that. It was a removable point. And it is a removable point at x equals 0. So again, we had this graph. It had a line. We didn't show it initially until we found it, but there's a hole there. That is a removable point of discontinuity. All right, so when I look at this one, so this one actually has a denominator, has x minus 3, and this one also has a square root, so it's got both of them. So I can say that x minus 3 equals 0, and if I solve that and I add 3 over, I now can say that x cannot equal 3. So I know that there's some type of discontinuity at 3, but I also need to take into account that square root. So remember I said if I have a square root, that means that whatever is inside the square root has to be greater than or equal to 0. So I have x plus 4 inside of the square root. So because I have x plus 4 inside the square root, I'm going to say x plus 4 is greater than or equal to 0. Well, it's greater than or equal to 0. I can actually solve it just like I did the equation. And I have that x has to be greater than or equal to negative 4. Now, I want you to think about this on a number line. So on my number line, we have two numbers that we've talked about. We've talked about negative 4 and we've talked about 3. So it says x is greater than or equal to negative 4. So that means I'm equal to negative 4, but I have to be greater than that number. I can't go less than. But I also cannot be equal to 3. So I have an open circle at 3 here. So we're going to be able to shade or include everything between negative 4 to 3. Skip 3, and then keep going to positive infinity. So if I state that in my domain, I'm going to say that my domain includes negative 4 to 3, but 3 is not included. Union, and keep going to the right and pick back up on the right side of 3 and go to positive infinity. So the question is what type of discontinuity do I have? Do I have a point, a removable point? Do I have infinite? Do I have a jump? So I'm going to put this in Desmos so we can look at it. So again, in the numerator, I had the square root of x plus 4. And then in the denominator, I had x plus 3. Oh, excuse me, x minus 3. All right, so I can clearly see that my graph goes no further than -4, and it is included because I'm able to click it. Now, what happens is I go through here and I see that I'm starting to level out and got this like vertical line going down, going down. This is also disconnected, and I have another vertical line that's leveling out. So if you remember, we said that x could not equal 3. There is an invisible asymptote at 3. So that asymptote means that there is infinite discontinuity at 3. Okay, so that one doesn't have a removable point. That one is just infinite discontinuity because it's going separate away. And then, of course, it does continue to go to positive infinity as we go to the right. And again, we were just talking about the domain here, but if I look at my table, now I don't see where that 3 value is there, but if I go to the table and type in 3, it will in fact tell me it's undefined because there is a invisible fence there called an asymptote, which makes it infinite discontinuity. Now, I know that there is quite a bit of pieces here. We will talk more about this algebraic part of domain and range. Right now, I just need to make sure that you know your discontinuities, and then you can graphically look at something and tell me the domain and range from left to right and bottom to top.